Hi everyone, welcome to the second leg of my capstone presentation. Today I'm going to be talking about some of the literature that kind of aligns with my project as well as some of the data transformations I've done. One quick amendment to point out, I will be narrowing the focus and scope to kind of focus on weekly fantasy performance of NFL players rather than overall performance. I think it's a bit better of a use case, and I was having some trouble scraping some of the data off on the websites. So same data, we're using player performance historically, kind of last week, the last 3 weeks from a time series standpoint, team performance, overall teammate performance, opponent performance, as well as location and weather and other external factors. So I'll be using a data set from Kaggle. This is a new one that I'll be posting on the discussion board that anyone can pick up and use if they want. Pro Football Focus that I'll be using for team performance and opponent, as well as the open weather map. So there's two use cases that align with my project. The first being forecasting next season's total points. So this is useful in understanding how well you think that player is going to perform this upcoming season. So at a high level, it's good for preseason rankings and insights. So the chart that I show here is essentially a set of quarterbacks and their projected 2018 fantasy points. Second being forecasting weekly points. So in fantasy football, you build a roster and you select multiple players at the same position and you use those players collaboratively throughout the season. So the player that has the better matchup, the one that you think is going to generate more points that week against the player or the person that you're playing against, that's the one you play. So here, Aaron Rodgers has a projection of over 21 points and his opponent is Chicago. So you may have another quarterback that has a harder opponent and isn't projected to score as many points. So this is good for in-season rankings and insights. So here's a research article that I found for kind of projecting next season's total points. It was actually a capstone thesis project. So the idea here is to predict player performance across kind of the NFL at a variety of positions. So his hypothesis was by leveraging autoregressive integrated moving average modeling, or random modeling, we can individually kind of forecast these independent variables and use those outputs, those forecasts, in order to project how well, from an overall fantasy points perspective, that individual is going to perform that upcoming season. So this is good for, I'm building a team, I don't know who to select, who do we think is going to generate the most points this season? Here's another look at it. So here's Aaron Rodgers' passing yards over the course of his career, right? So you can see that high level of variability, but the idea here is to use kind of his sum of recent averages in order to forecast how well he's going to perform this upcoming season. So that's what that's. Second, here's some limitations. It's a univariate methodology. There's a lot of interactions happening here between these data elements, so I think it's important to kind of harness that and you leverage it. There's also a high level of variability due to injuries. So at the beginning of a game, someone could get injured, and it's hard to account for that stuff. So my proposal is to do a weekly prediction. So that's the difference. It's a different use case, but that's kind of what I'll be focusing on, and to kind of adopt this time series element in terms of historical performance over the recent weeks in order to kind of capture that time series element, but also kind of account for some of that variability. The second use case is forecasting weekly points, which is what I'll be working on. So here's an article named Predicting Fantasy Football Production for FanDuel. So FanDuel is an application where you can build a weekly team and then use that team against a pool of opponents and try to kind of pretty much make money. So the hypothesis is that you can gain a competitive edge if you're able to predict how well players are going to perform. So if you know how well they're going to perform, you can build a better team and you can essentially win more money. So this is what they did. They had some, they did well in other areas. They didn't do well in all areas. They did well in some. So you can see the tight end or TE position. They had some relatively good success kind of predicting performance. I'm not surprised to see that because that position kind of has very low levels of variability in the performance. You're not going to see a lot of people doing really, really, really well and a lot of people doing really poorly. It's kind of par for the course for the most part. some of the algorithms they used where they had some success were the tree-based, gradient boosting, and random forest. Some limitations, they had opponent features, but they didn't use anything which could provide some insight into how well their team is and their teammates. They had no element of time to account for that variability around kind of injuries and how the game flow was moving. And they didn't have any external variables such as weather, location, etc. So I want to include some of those teammate features in terms of how well that team is performing holistically, as well as, which I already introduced, but that recency of performance. So here's some data cleansing. There's a couple of scripts that I wrote for some of the data that I have. So kind of, taking datetime fields, converting them to string in order to create primary keys for those weekly matchups to append that additional data that I'll be using as features. So generating primary keys from that, creating position-specific data frames, and then deriving the weekly fantasy points, which is really important. So at each position, there's kind of an algorithm in order to output how many points he kind of accumulated that week. So here's a couple of insights I wanted to show you guys. We're going to focus on the top part real quick. So the blue line is essentially how many points, and this is Steven Jackson, who's a running back, he's now retired. In 2014, he was accumulating, as you can see, kind of up and down. And the orange line is how well that team is performing, or how well that week that the opponent is at stopping the run. So he's a running back. So as the orange line increases, he's playing against tougher opponents. So you would expect that as those opponents are kind of better at stopping the run, his performance would go down. You can kind of see that there. The second is, and it's the same kind of data from the blue standpoint, the blue line, but I created a ratio which is how well his team is at kind of blocking for running backs, or how well the team blocks in general, over how kind of good the defense is, or that opponent is at stopping the run. So it's a ratio. So as the ratio increases, you would expect the performance to increase, and you can kind of see that. These are much more aligned. So these are some of the features that I'll be using. Here's 1 week, not really sure what happened. Could have been an injury, maybe he got pulled from the game. As you can see, that ratio increased, but his performance did not. Here's Todd Gurley, so you can see that same, he's a really well-known running back that plays today, and you can see those same kind of things here in the visualization, right? So you kind of see that those crisscrossing features there at the top, and then you can see that they're aligned here in the bottom, so you can see when that ratio increases or decreases, his performance kind of aligns with it. So I thought those were a couple useful insights from a running back standpoint, and I'll be sharing more of these as I go. That's all. So I appreciate you guys for listening. If you have any questions, please drop them in the discussion board, and I'll be sure to answer them as soon as possible. Thank you.